This week, a very large running race occurred in Denver. The times were normally distributed with a mean of 22.08 minutes and a standard deviation of 2.46 minutes. What percent of runners took 22.326 minutes or less to complete the race? The first things that I notice here is that the times are normally distributed. So that helps me identify how I'm going to go about solving the problems. So each of the problems are going to be solved using either inverse norm or normal CDF functions from the calculator. Those are the ones that help us with normal distributions. The first problem asks what percent of runners took 22.326 minutes or less to complete the race. So, in order to answer this, what I need to do is draw a bell-shaped distribution, labeling the pertinent information. So the mean is 22.08, standard deviation is 2.46. 22.326 is slightly larger than the mean. I'll put that about right there. And if I want a percentage that's that value or less, then I would shade to the left. So I'm trying to figure out this area under the curve. And to do that, I use the function Normalcdf within the calculator. And Normalcdf takes 4 inputs. The first 2 inputs are the lower bound, which in this case would be negative infinity. But there's no infinity key on the calculator, so we'll use negative e to the 99. And what that means is effectively negative 1 times 10 to the 99th power. The upper bound of our shaded region is 22.326. And then we give the mean and the standard deviation. Now using the calculator, we'll come up with our answer. So under the distributions menu is where I find Normalcdf, so second in vars. And the inputs I give are negative. Be careful not to put a minus, usually a negative symbol there. Then hit second in comma to get an E, then 99. Then 22.326. 22.08 and 2.46. So inputting our data separated by commas, we come up with the probability that we're looking for, 0.5398. And I'll use 4 decimals as that's pretty common for normal distribution probabilities. Now, it's possible that you had seen a menu show up whenever you did your Normalcdf. And some of the later model calculators do that. And the menus are there to just help be reminders as to what inputs you give the calculator. So the inputs that you give are the lower and upper bounds, and then the mean and standard deviation. And here it just allows you to type those values in as you see them. You don't have to put commas here, as the calculator will insert those for you after you hit paste. As it just takes those numbers and puts them right into Normalcdf for you. So either way, you'll get the same answer. Inverse norm. But to show you how that's done, I still always recommend drawing a distribution to get yourself organized and get the information in the right place. So the mean of this data is 22.08, where the standard deviation is 2.46. All right, that mean is right in the center, and it's measured in minutes, okay? Which means this entire axis is measured in minutes. So a value that we're looking for is a time in minutes, so it's some value along this axis, and it's the cutoff for the fastest 9.07%. So, for instance, if you think about running times, the fastest runners are going to have the lowest times. So the fastest 9.07% would be down here to the left. And that area right there is going to be 9.07% of the data. And x is the value that's missing that we're looking for. So to find that value, we're going to use the inverse norm function. It takes the area to the left of an unknown value, and that area to the left is 0.0907 when we change it to a percentage. And then it takes the mean and standard deviation as the last two inputs. And the output is a value relative to the mean and standard deviation and their respective units. So, inverse norm So in the calculator, I'll go to the second invars, which gives me the distributions, and come down to inverse norm. Area to the left is the first input, so 0.0907. And if you don't get the menu, that's okay. Just enter your data into inverse norm, separated by commas. The mean is 22.08, and the standard deviation is 2.46. When you hit paste, the calculator just places that into the inverse norm function for you. And after you press enter, you'll get the answer, which I'll round to 2 decimals just to match the accuracy of the mean and the standard deviation, but follow any rounding rules provided in the problem. What percent of runners took more than 15.93 minutes to complete the race? So let's take a look. The mean here is 22.08. The given value here is 15.93 minutes. So of course that goes on labeled on the x-axis because it's in terms of minutes. More than that would be this area here. So to find that area under the curve, that's where we use Normalcdf. The bounds of the shaded region are 15.93 and positive infinity. Then the mean and standard deviation haven't changed throughout the problem. So we'll just repeat those. Then use the calculator to come up with our answer. So that is 0.9938. And if you're required to write it as a percentage, just make sure to multiply by 100 and append a percent sign if required.